Okay, we just did a quick review problem at the beginning of class here where we graphed all of these. These are called constraints. So when you have your test, they're going to say write equations for the constraints. If you're constrained, it means you're like held back. So this is constraining part of the graph. It's saying basically it can only be underneath this line. It can't be above it. It's constraining it to that area. And this whole thing, when we were all done, do you remember it starts with an F? What's that thing called? Feasible region. Okay, and do you remember me saying that only this point, or this point could be the final answer? What if we are trying to maximize? Well, then it's hard to know, but it certainly isn't going to be what? 0, 0. Now, how can I not know? Well, it depends what you're trying to maximize. Maybe x's are worth 10 each, and y's are only worth 1 each. Well, then this would be 4 times 10 is 40, and that would only be 2 times 1 is 2. Well, clearly this one wins. But if I make y's worth 50 each, and I have 2 of them, maybe this is profit, and I get a lot more profit from selling y's than I get from selling x's. It's kind of like the iPhones that have come out. They make a fair amount of profit for Apple. They're a good profit maker. Some other things that they make don't make them nearly as much profit on each item. I don't know where the iWatch stands, except I would bet that the expensive ones make them a lot of profit, because they're going to sell like solid gold iWatches, $10,000. It's going to be interesting to see how those go. I have to admit, if somebody gave one to me, I'd gladly take it. It'd be really cool. Would I spend $10,000? No way. Not personally. But then again, I'm not their ideal market there. They're looking for the people who buy expensive stuff, buy expensive watches. I'm the guy who, the big splurge I make is for the iPhone. Otherwise, I don't have much expensive tastes. All right. So anyway, these might be more profitable. And so if I only have 2 of them, but if they're way more profitable, it still could be more than this spot. All right, you'll be able to do that better once I do a whole problem with you. It's called a profit maximizing function. All right, so I want to turn to the notes that we had yesterday just for a minute. They looked like this, and I'd like you to get there if you haven't already. I told you before, so hopefully most of you are there. And here is a typical question. Mrs. Roush went to the grocery store to buy jelly beans. She wants less than 5 pounds of cotton candy flavor, less than 5 pounds of cotton candy flavored. Well, for one thing, you got to pick what's going to be X and what's going to be Y. So you can really only compare 2 things here. We're going to go with cotton candy compared to buttered popcorn. And that's the first thing the teacher does in this problem, is they pick, let X be the cotton candy. Could you have done it the other way? Yeah. Unless the problem says so, you could do it the other way. But X is going to be cotton candy, and Y is going to be buttered popcorn. You have to pick that. Okay, then do you get how you'd write an equation? If you know that the cotton candy is going to be X, do you get this has to be X is like greater than or less than or that kind of thing? All right, so then the equation for that is less than 5 pounds. X is less than 5. Done. Do you see how that is on the graph? Here's the 5 line for X. X is 5. And it's less than means it was shaded this way. Why is it a dotted line? Because it's a less than sign. What if it had been an or equal to? Then they would have made it a solid line. Okay? All right. Next, if Y is buttered popcorn and we have at most 2 pounds, at most, that means should it be more than 2? No, less than 2. Or could it be 2? Could it be 2? At most 2. Yeah, it can be 2. So it has to be less than or equal to 2. And this must be Y because it's the popcorn. And so I go Y is less than or equal to 2. You get how this line right here is Y equals 2, and it's shaded underneath it, less than it. So the only difference is they're going to give you stuff in words. You're going to translate that into X's and Y's, make equations for them, and then graph them. You already know how to graph them. We did that yesterday, and we just practiced it today. So now it's more about making these lines, making these equations. And then finishing off the problem. Well, in this case, it's simpler because all they ask you is to sketch it and represent all possible combinations that she could buy. That means she can buy anything in this shaded area and be okay according to her like rules for herself that she needed to get, you know, less than 5 of these and more than 2 of those and whatever. Okay. In the more complicated questions, they're going to say like, okay, and let's say she's buying these things to sell them in another country. Some people do that. Like, for instance, a guy got caught with rhino horn, and he's going to go to jail for a long time because rhinos are protected. And people in China, some people in China, believe that if you eat rhino horn, that it will cure you of cancer. Now, if you really truly believe that, wouldn't you pay a lot for this stuff that would cure you of cancer? Of course you would, if you had cancer, or if your mom had cancer, or whatever, and you really believed it. Well, sadly, rhino horn is the most expensive commodity in the world. It is more expensive than platinum, or gold, or you know, any other commodity. It is the most expensive. You can look it up. There's a story just the other day on it. So basically, ground up rhino horn powder. Think about how light it is. And they sell it for ridiculous amounts because nobody buys a pound of it because it's like a powder. So anyway, and you can imagine then how that sets up the people living near where the rhinos live that are incredibly poor, and they can go poach a rhino, kill the rhino, get the horn, and sell it for the most expensive substance in the world. You can imagine how that goes. I mean, there's a lot of poor people who are like, don't care if it's illegal, don't care if I get caught, I go to jail. I'm going to go catch me a rhino and I'll have lots of money. And so, anyway, it's a sad situation for the rhinos, especially because it doesn't work. It's like all of this pain and suffering of, you know, like trying to hunt down the rhino killers, and the rhinos are getting slaughtered and they're going extinct, all because it's a total myth. I mean, if it cured cancer, we would all be like, there'd be rhino farms in the United States, like growing rhinoceros like crazy so that they could harvest them so that they, anyway. Yes?
In this one, it says X and Y axis help to make it feasible region.
I see your point. It doesn't ever say that you have to have a line right here, does it? But just logically, can you have negative jelly beans or negative buttered popcorn? And so those are what are called the common sense constraints. And you should put them in for yourself. I always get confused on this. What I have to do is this. Okay, that's the y-axis, so it's x equals 0. And this is the x-axis, so it's y equals 0. And you should always have y should be greater than or equal to 0, and x should be greater than or equal to 0 as part of your constraints. Unless you're doing the rare problem where you actually can have negative things. Golf scores is the one that always comes to mind. You can have a negative golf score because you can go below par. And anyway, but almost every problem you're going to say greater than or equal to 0 and greater than or equal to 0 for both x and y, because in the real world you can't have negative rhinos or whatever. Okay, so the cool part about these is they're real world problems. You could actually, if you had these constraints for a business, I have a small business. If I knew all of these constraints, I could easily just graph it and I could say, yeah, I should be selling mostly this kind of insurance policy, or maybe it's about marketing. And I could say, okay, knowing everything I know about how much I pay for each click that people, to bring people to my website, if I can pay $1 per click to get them to come to my website, and only 1 out of 100 of them actually buy, it's still a good deal, because if I get 100 people to come and 1 person buys, and I make $200 profit from that 1 person, hey, I spent 100, I got 200, I made money. You can use this in the real world. You can actually figure out stuff like, okay, how much should I be spending on my pay-per-click program? Sad, when you go to Google and you click on a thing, did you know that most of those people are advertisers and they are paying money every time you click? And so, like, you click on, there's one that is the most expensive pay per click. Insurance runs about $5 per click. You click on an insurance company's website, like Allstate or whatever, because they're advertising and trying to get you to come to their site. They'll pay $5 because you clicked on their ad. Just you at one time, $5. Anyway, the most expensive one out there, it's over $100 per click that lawyers have to pay. It's for mesothelioma. Have you heard of that one? You probably saw it advertised on TV. That's that kind of cancer you can get in your lungs from asbestos. Because if they can get one of those customers, they pretty much have a slam dunk case against all these companies. There's actually this huge fund that's been set up because a lot of companies sold this stuff which caused people to get cancer. And there's a huge fund that's set up that they can get money from. And if the lawyer gets involved, he can have a cut of it. And so it's like $100 per click. If you search on mesothelioma and you click on some lawyer's website, he's going to pay $100, whether or not you do anything. Okay, so just trying to give you examples of how in the real world you could actually use charts like this to, get some real results. Okay, now let's actually do one. So everybody find your homework for today, which is under day 2. So I'm going to go back here and find day 2. And it's worksheet A and B. I'm going to assign some of the problems today, and we may do some of them tomorrow as well. And this top one says notes, because basically we're going to do it together. And I'm thinking of it as this is your first homework problem. I'm just helping you do it. Okay? So everybody find this one, 6.6a, linear programming practice. Kesha is a college student who's majoring in mathematics education. She would like to earn some money to help with expenses. She has 2 part-time jobs. Do you see an X and a Y setting up right there? I hope you start thinking that way. She earns $8 an hour tutoring. And whenever I see stuff like at the academic support, I try to just sort of skip over that. $8 an hour tutoring and $10 an hour at the restaurant. Aha, that's 2 different things. And right away we should pick, and it has actually picked for us. X is the academic support center, which is the tutoring part, and Y is the working at a restaurant part. Okay, I need to pause for a second while I get my smartboard to be able to write on it, so hold on a second. Okay, I'm back. Here we go. So now I can write on the board. So X is the tutoring and Y is the restaurant hours. And it's $8 an hour tutoring. So here it is. Here are some things that, I'm sorry, I shouldn't have started with $8 an hour. It's actually asking me for the hours she wants to tutor. All right, I got to look through the problem and try to figure out where that says that. Although she would like to work more hours at the tutoring center, she likes to earn the higher pay at the local restaurant. She can tutor no less than 2 and no more than 8 hours per week. There's the sentence. No less than 2 and no more than 8. So then, for this question, the hours she wants to tutor, you put the X here, you put the 2 here, you put the 8 here, and you just got to be careful with like the signs you want to put in there. Now, actually, now that I'm realizing, they said write 2 constraints. I probably shouldn't try to write this as one big thing like this. I should probably write it as 2 separate statements. Sorry. X is, let's see, no less than 2. Well, it sounds like less than 2, but no less than 2 doesn't mean not, it means not less than 2. So if it's not less than, what does it mean? Okay, so it should be greater than 2. Now, can it be 2? You got to look back at it and always ask that question. So, no less than 2. Does that imply you can be 2? Yes, they should say equal to. There we go. So writing these equations is picky business. You got to be really careful with, like, should it be greater than, should it be less than, should it have an equals or not? All right. Caleb, the next one. All right, now ask yourself the question, can it be 8? There's no more than 8. Could be 8, so what should I put? Or equal to, there you go. Always ask yourself that, because that's the biggest thing. Everybody knows it's 8. The question is, can it be 8, or should it have to be just less than that? All right, there, I got the 2 done for the hours she wants to tutor. The next part here, the number of hours she can work at the local restaurant. Common sense constraint. What's the common sense one? And this is tutoring or restauranting. And therefore it's Y. Y is what? Common sense. Greater than or equal to 0. She could work 0 hours at the restaurant. Does it say that she has to work a certain number of hours at the restaurant? There are jobs like that. Doesn't say though. Okay. Total hours she can work during 1 week. Total hours she can work during 1 week. Well, in general, most people look to go for 40 hours a week. They're full-time, but she's a student, so, here it is. A total of no more than 20. So, how do I say total? It involves an X. It involves a Y. X plus Y. Total of, and then how do I say no more than 20? Less than or equal to 20. You get how now? It's just like the problems I just asked you to do before, except we had to write the equations, so it was harder. But now that we've got the equations, you would graph it the same exact way as before. And we don't have to actually do that yet. It hasn't asked us to. But these are those constraint equations that we gave you before. Now you got to create them yourself. All right. Pause for a second. Okay, I'm back. I've got it set up so I can write on it now. Graph the system. All right, so that's exactly what I was saying we didn't have to do yet. Now we do. Got to graph this thing. So I'm going to pull up some graph paper here. And if you want to insert the graph, that would be very smart on your part. Make your life a lot easier to insert a graph from your memory on your iPad. Did you get, I'm really not going to need anything more than the first quadrant here? At least I won't have to go negative. I might have to count up a little higher on it. Okay, and what were my constraints again? I have X is greater than or equal to 2. Okay. So I'm going to use my drawing tool here. Oh, that's a dotted line. That doesn't work for this because it's a solid line because it says or equal to. Greater than or equal to 2. Okay, so I'm going to shade just slightly above that. And less than or equal to 8. Oh, those are X's. Sorry. X is greater than or equal to 2 and less than or equal to 8. Okay. Okay. Rats. There's 2. There's 8. Less than or equal to, greater than or equal to. Okay, I got those 2 graphed. Now it's Y is greater or equal to 0. That's a common sense constraint. You can't work less than 0 hours. And last one, X plus Y is less than or equal to 20. This one's the one that messes people up usually, but this one's pretty easy. Subtract X from both sides. Y less than or equal to negative X plus 20. Why did I put the negative X first? Because that's where the slope goes. I'm going to put this like that to remind me how my slope looks. My y-intercept is 20. Oh, man, that's way off my graph. That kind of sucks. Okay, so how am I going to do that? I'm just going to cheat. I didn't need my numbers before, so I'm going to make this 5. 10, 15, and 20. I didn't need my y-axis numbering until now, so it's going to work out okay. So I'm going to start with a y-intercept of 20, and then I'm going to have a slope of -1. And if this goes out to 20, which would be like over here, then it's going to have a slope of -1, means it goes down to there. Now, it's underneath that, less than or equal to, so there. Now again, yours might look a little different if your x and y axis are labeled the same. Mine is like twice as long on my x-axis, so that kind of may be skewing how my box looks, but that's basically the feasible region. And now it actually means something. This lady, this girl, this young woman, is deciding how many hours to work here and there, and she's figured out that she has to work a number of hours that's in this box. Now, is there one of them that'll make her more money than the other? Remember me telling you that the answers are either here, 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 or here? Now, is making money your only goal in life? I hope not. Okay, if your only thing is you want to make tons of money, then there's lots of really bad things you can do in this world that will make you tons of money. Now, that's not to say you couldn't find a good thing to do that also makes you tons of money. That's okay too. But you shouldn't judge your life just on what makes me more money. But if she's a poor college student, she's like, oh, I'm dying for money here. I need more money. And she says, what can I do to maximize how much I'm making? Then I guarantee you it's not one of these. Which one, A, B, C, or D, would you pretty much guarantee is not going to make you the most money? A is got to be out. Okay? But B, C, or D could be it. How do we tell? That's what these next couple things are, the next couple questions they ask us. Write an optimization equation that represents her earning potential. I'm going to use P for profits, even though that's usually reserved for businesses. If you are an individual worker, your profit is what you have left when you get done the day and you got paid. Okay? So her profit, and this will also work later when we're doing profit for companies. Her profit is, she makes $8 an hour for each hour of tutoring, which is X or Y. I think X is the tutoring. I'm going to double check that. Yep, X is the academic support center, so X is tutoring. Okay, good. 8 for each X. I bet you can finish it now. It's real easy. She'll also make, so you have a plus, what? Yep. And do I really want the $sign in there? No, it's just kind of cluttering things up. So 8 for each X, 10 for each Y. Now that you've got this equation that involves X's and Y's and tells us their total profit, we can take those points, the vertices of the feasible region, and see which of them actually makes the most money. Because you get 8 for each X and you get 10 for each Y. So now I go back to here, and my choices were 2, how do I tell where those two lines cross? Well, let me show you something that's really handy. Your graphing calculator. You grab your graphing calculator. Because it might be really hard for you to tell where those two lines are crossing. But your calculator can tell you in like 2 seconds. We have to put in a way, these two lines. This line and this line on your calculator. But do you get that this is an X equals line? And you can't type that into your calculator real easy, but that's the thing you get when you hit value. It says X equals. All right, so what we need to do is just type in this other one that's a more normal one. Remember this one right here? Type that into your calculator, so you can just say -1 or just -X plus 20. I'm going to put up my calculator. Okay, I got my calculator going here, so I'm going to type in -X plus 20. The negative sign, x plus 20. Now, if I graph that, there we go. How do you get a vertical line? Vertical are x equals things, right? Do you remember me giving you a hint before? Where do I find this? For an x equals? You can't just go back to here to y equals. That says y equals. So I'm on the graph. How do I get to x equals? Second calc, good. And the value, the top one. And notice how it brings up a blinky x equals. Okay, x equals what? We have to go back to our picture. Please don't just watch me do this. Do this on your calculator. See how it's this line right here is at x equals 2. So I'm seeing where the two lines cross right here. And you're going to really want to know how to do this for your calculator. Okay, x equals 2. Enter. Boom. There it is. 2 comma 18. Now this one happened to work out nice. Some of them won't work out so nice. Like if you would have drawn your graph really carefully, you'd have been able to see it was 18. But when your graph is a little sketchy, or when the two lines don't meet at a nice point like 18, what if they met at 17.7? Would you be able to read your graph well enough to tell that? No. So that's why your calculator is going to be handy for this. All right, that spot's 2 comma 18. So now I can go down here and say, okay, the 4 vertices that you have to write down, the 4 places it could be, 2 comma 18 is one of them. How about this spot? Well, that's where the line hits x equals 8. So I'm going to go second calculate a value. A value of x equals 8. And it's further over, and it's 8 comma 12. Now I know this spot is 8 comma 12. So I got 2 comma 18 and 8 comma 12. This one's a little easier to see. It hits 0, right? So then I know it's 8 comma 0. And this last corner is also right on the x-axis, so this corner is easy. It's 2 comma 0. Those are my 4 spots. 218, 20, and 812 and 80. So I put those numbers into this. And here's how I recommend you make your little chart. You go like this. You say this is x comma y, and we had 20 as one of the options, and I'm okay with you just being smart and ruling that one out. Don't even test it. You know that she's not going to make enough money if she only does 2 hours of one of the jobs. Okay, but the other one, and the 8 comma 0, do you agree that that's probably out? But it might be actually okay because it's the higher paid job for 8 hours. And there was, help me, what were the other one numbers? 2 comma 18 and 8 comma 12. I'm guessing it's one of these two, but I'm only going to let you rule out that one by the origin. You need to show me the other 3. So now we're going to stick these into that profit function, which once again was profit equals 8 for each x plus 10 for each y. Now, if we stick in 8 for each x and 10 for each y, then the first point we're doing here of 2 comma 18 would be 8 times 2 is 16, plus 18 times 10 is 180. She'd make a total of $196 if she does the 2 comma 18 route. And in the real world, what does that mean? That means 2 hours of tutoring and 18 hours at the restaurant. Makes sense. You maximize the one that gets you more money. Sir?
Wouldn't you always count it out if there are 2 sets of numbers that are the same one, but the second one is smaller than the other, like the 8?
I see what you're saying. You're saying that logically, there is no possible way for 80 to work if there's an 812.
Yeah.
I gotcha. And yes, because these are both the same, then you're right. But there are problems where the factory should make all motorcycles and no Jeeps. So there are some where there's a 0, but if they can make some Jeeps, or same number of Jeeps and more motorcycles, of course they'll make more money then. So you're right. Logically, we can rule this one out because there's another option that has to be more money because we got 12 extra Y's with it. So anyway, 8 times 8 on this next point, 8 times 8 is 64, plus 10 times the 12 is, 10 times 12 is 120. That one makes her $184. Now, obviously, if you're just worried about the money, 196 bucks, much better deal there. Now, do you get how, so this point is your answer. How many hours should she work? Okay, X is 2, so that's 2 hours of tutoring and 18 hours of restaurant. Well, what if she hates her restaurant job? Do you get how she might choose that other option? Because she at least makes some more money at the restaurant, but maybe she'd rather have the 184 bucks. I mean, wouldn't you, if your life's way better, choose to make 184 instead of the 196? You know, what if your boss is a jerk? What if the customers are, you know, being mean to you or whatever? And you'd probably rather do lots more hours of tutoring. So, and it's still pretty close. Still a total of 20 hours, and it's not that far off in income. So, okay. So this is the, if you were Kesha, what would you decide? Defend your answer. Well, answer any, that's obviously a judgment call. I'm just trying to bring up that it's true in the real world. You don't want to make your life just dependent on what makes me more money, because that doesn't always make you happy. It is a dreamy situation if you can get paid really well for doing something that you really love. That's ultimate. Okay, so I would say our assignment of this worksheet, 6.6a, part 1 and 2, we did the first problem together there, is, you know, that you've got the outline of how to do these. The hard part is usually writing the equations. After that, it's really not hard. You just graph them, see where they cross. Calculator can even tell you where they cross. So let's get started on one more of those, and then I'll have to decide exactly how many of these I'm going to assign you for homework for tonight. We're done with the Kesha problem. All right, this next one is the burritos, Eli's lunch cart. And it does say let X be the burritos and Y be the chili. So, but it doesn't give you all the little helper questions in between. Like, you know, first let's find the constraints for the burritos. Next, let's find the constraints for the orders of chili. Okay, so it doesn't give you quite as much help. But it's the same basic process. So I think since the equations are the hardest part, I'm going to help you get started on that part. All right, so they sell burritos and chili. To stay in business, they must sell at least 30 burritos. That sounds like an equation. So right away, I'm going to go grab my pen and go, okay, burritos. Let's see if I can, maybe I can write if it's in a PDF. Maybe I can write right now. Not right now. Maybe if it's in PDF form. Yes. Okay. X is the burritos, at least 30 burritos. X is it less than or greater than? At least 30. Greater than or equal to 30. Good. And 10 orders of chili. That implies at least 10 orders of chili. X has got to be greater or equal to 10. Is there common sense involved with burritos and chili? Can you have negative burritos or negative chili? So then you should write an equation for that. Oh wait, I think I just did something wrong. The chili is supposed to be Y. I made it X. Sorry. No more than 40 orders of chili. Okay, chili is the Y. Y has to be less than or equal to 40. Or 70 burritos, that's back to X. X is less than or equal to 70. All right, I would like you to do Eli's lunch cart and the one after that that's on your assignment. Just do that problem and the one after it. Okay, so that gives you 2 problems. I know they're biggish, but that should be about 20 minutes or so. That's my goal. That's all I got for you for today. Have a good day.